In today's lesson, we're going to take a look at angle pair relationships. We're going to not focus as much on a formal proof in today's lesson, but more of the application of some of these things. So the first thing that you see is theorem 2.3, which is the right angles congruence theorem. And it's pretty self-explanatory. This just says that all right angles are congruent. And really that kind of makes sense because all right angles are going to be equal to 90 degrees. So of course they have to be congruent. Next up is the congruent supplements theorem. So this says that if two angles are supplementary to the same angle or to congruent angles, then we know that they have to be congruent. So this theorem isn't quite self-explanatory. It's a little bit confusing, in fact, when we look at just the words. So let's take a look at this diagram below, and let's look at the next statement that we see here. So this is saying that if angle 1 and angle 2 are supplementary, so we know those two angles add to 180, and we know that angle 3 and angle 2 are supplementary, so those add to 180 as well, then we know that angle 1 and angle 3 have to be congruent. And when you really think about it, I mean, it kind of makes sense because if I'm saying that these add to 180, so let's come up with a number. Let's just say this is 40 and let's say this is 140. So if that's true, then if these are supplementary, then 3 has to be 40 because it's adding to the same thing. So we know that then 1 and 3 have to be equal to the same measure. So if they're both supplementary to another angle or to the same angle, then those two angles have to be congruent. All right, the congruent complements theorem, basically saying the same thing, except now we're talking about complementary angles. So this says if two angles are complementary to the same angle or to congruent angles, then we know that they are congruent. And we'll take a look at kind of a visual here as well. So if angle 4 and angle 5 are complementary, so if those two angles add to 90 degrees, and we know that angle 5 and angle 6 also add to 90 degrees, they're also complementary, then we can conclude that angle 4 must be congruent to angle 6. And really that's because they're both complementary with angle 5, so they have to be equal to each other. All right, the linear pair postulate. So this says that if two angles form a linear pair, then we know that they must be supplementary. When we started looking at angle relationships, we really already talked about this. We know that a linear pair forms a straight angle, and we know that a straight angle consists of 180 degrees. So we've kind of already talked about the fact that the linear pair is supplementary. Here is just the postulate that kind of states that. So this is saying angle 1 and angle 2 form a linear pair. We know that angle 1 and angle 2 are supplementary. So we can say in symbol form that the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. All right, next up is the vertical angles congruence theorem. We've talked about this a little bit, but we really didn't discuss it formally, and we haven't really used it all that much. So this says that vertical angles are congruent. So we probably need to refresh what a vertical angle is since it's been a little while. So when we look at our diagram down here, remember vertical angles are going to be the ones that are kind of across from one another. They are going to have, the angles are going to be formed by opposite rays. So when we look at this diagram, angle 2 and angle 4 would be vertical angles. Again, across from one another, you see that the rays forming those are opposite rays from the other angle. Likewise, we would have angle 1 and angle 3 as being vertical angles. So this theorem is saying that the measure of angle 1 has to be equal to the measure of angle 3, and the measure of angle 2 has to be equal to the measure of angle 4. This really kind of goes back to that congruent supplements theorem because we see that angle 1 and 2 are supplementary. 2 and 3 are supplementary, so 1 and 3 have to be equal to each other since they are supplementary with that same angle, with that shared angle. But we do have this theorem that kind of allows us to shortcut that piece and just say that the vertical angles are congruent. So let's go ahead and let's apply that to this first problem here. So we have a set of angles. We know that the measure of angle 4 is equal to 63 degrees, and we want to find the measure of angle 1 and the measure of angle 2. So let's go ahead and let's start with the measure of angle 1. When we look at the measure of angle 1, well, let me in my diagram label that 4 is 63. So we know that the measure of angle 1 is going to form a linear pair with angle 4. So we know that those have to add to 180. So to figure that out, we can just take 180 minus 63, and you should come up with 117. When we look at the measure of angle 2, that one's actually going to be even easier because we see that 4 and 2 are vertical angles. So we know it just has to be the same measure. So angle 2 is going to be 63 degrees. All right, so I want you to pause the video real quick. Take a look at that next one. If the measure of angle 3 is 121, find the measures of angle 1, 2, and 4. So pause the video, and then when you're done, resume playing and check your answers. So for this one, you should have come up with measure of angle 1 being congruent at 121 degrees. Measure of angle 2 is going to be supplementary with that, so that's going to be 59 degrees. And then angle 4 is going to be congruent to angle 2, so we know that the measure of angle 4 has to be 59 degrees as well. All right, moving down to some slightly more complicated problems that are going to involve some algebra skills. So in this one, we want to write and solve an equation to find x, and then we're going to use x to find the measure of angle FKG. So when we look at our diagram, we look at what's being given to us, we see this angle here, FKG, is going to form a linear pair with GKH. So we know that those two angles must be supplementary or must add to 180. So I'm going to take my first angle, which is 4x minus 1. I'm going to add my second angle, which is 113. And I know that their sum must be 180 degrees. At this point, just need to solve that two-step equation. So I will combine like terms first right here, and then subtract the 112 to both sides. And then lastly, dividing by 4 gets me an x value of 17. So I know that x is 17. We have to remember that we are not done because we're going to use x to now find the measure of angle FKG. So FKG is this angle right here that was involving that expression 4x minus 1. So we need to substitute 17 in for x. And when you simplify that, you should come up with 67 for the measure of angle FKG. All right, moving down to the next and last example. So for this, we see an additional expression here. So we see two algebraic expressions. If you notice, these are vertical angles since they are right across from one another. So we can use our vertical angle congruence theorem and know that those have to be congruent. What we're going to do is we're going to create an equation. We're going to solve it for x, and then we're going to use that value for x to find the measure of angle AEB, which is what we're asked to do. So our equation, since these are congruent, we're going to set these two expressions equal to each other. And then we're just going to solve for x. So I'm going to subtract 3x first. And then add 18 to both sides. So I'm getting an x value of 22. We're trying to find AEB, which is the angle on the left over here. So we're going to substitute 22 in for x. And when you simplify, you should find that the measure of angle AEB is equal to 70 degrees. All right, so that's it for our notes today, folks. Again, just looking at some additional theorems and postulates involved with angle pair relationships, and then applying them to be able to solve some of these problems. So that's it for today's notes. Have a great day, folks.